Hey guys, this is the lecture video for t-tests. So let's get started with talking about our chapter objectives. So we have 4 objectives for this particular module. So for this one, we are going to talk about a t-test for independent means, a t-test for dependent means, how to use the data analysis toolpack for both of those, as well as how to write results in APA format for both of those. Now this module is covering 2 chapters, essentially, one over independent t-test and one over dependent t-test. So let's talk about what a t-test is. So essentially, a t-test is looking at 2 samples that are statistically different from each other. So I want you to remember T for 2 for this particular mnemonic. So T for 2, we have 2 samples and we're trying to see if they are different from each other. Okay, so for example, if we want to compare 2 samples or 2 conditions or 2 groups, we would use a t-test. And I'm also going to add in there, if we have 2 times, we're going to want to use a t-test. Okay, so it could be like a before and after some sort of intervention, we could use a t-test. If we're using 2 different groups, for example, if we're testing the differences between male and female, we would use a t-test because there's 2 groups. Now before we go any further, we have to talk about a new concept. It's called degrees of freedom. So degrees of freedom is basically a mathematical way to approximate the sample size. Now we talked about sample sizes and populations already in this class. Now that is going to come into play when we look at group differences. So we're going to talk about degrees of freedom for the next 4 weeks, but however, the degrees of freedom is going to be different based on the test that we are talking about. So I'm going to insert degrees of freedom within the lecture videos when talking about how to write it up in APA format. Okay, and I'll talk a little bit more about why degrees of freedom is important when we get to that point in this lecture. So hopefully by now you figured out that I like steps, 1, 2, 3, 4, 5, 6. Okay, I like sequential instructions. So how to compute a t-test. First, state the null hypothesis. We've done this already. We've been doing it for several weeks. Key phrases for the null hypothesis for a t-test have to be specifically no difference or equal. So if I'm going to say male and female have equal happiness, or I can say there is no difference in male and female happiness. You cannot use relationship with t-test because that is not what we're examining. Remember, the basic definition of a t-test is looking at differences between your groups. So you have to use the phrase no difference or equal. Now, step 2, set the level of risk. We talked about this in my inferential statistics lecture. The level of risk is always going to be standardized at 0.05. So step 2 is kind of a gimme. Step 3, select the appropriate test statistic. So here's where we get into the weeds. We have 2 options for t-test. You have an independent samples t-test and a dependent samples t-test. So one of the important things with computing it is selecting the correct one. I'm going to talk about that more in a minute. Compute the test statistic. This is where Excel comes in handy. Since we have 2 different t-tests, there will be 2 different ways to compute Excel. We will talk about those as well later. Step 5 is to decide to accept or reject your null. Now, as I mentioned before in my inferential statistics lecture, if P is less than 0.05, you reject the null. If P is greater than 0.05, you accept the null. If you need to rewind that and write that down, I would highly recommend that so that you have that somewhere handy. The last step is to write your results in APA format. Now, I don't mean abstracts or cover pages or in-text citations or references. There's a very specific way to write about t-tests in APA format. There are 2 pieces to it, and we'll go through both pieces within this lecture. Okay? So let's talk about t-test for independent samples. This is the first kind of t-test that we talk about. So for an independent samples t-test, there are 2 groups that are being tested one time. And the way I've got it phrased here in the PowerPoint, 2 groups of different subjects that are being studied under one condition. So it's an independent samples t-test because the 2 groups are completely independent of each other. So an example of this would be males versus females. Some people are male, some people are female, 2 different groups being studied. You could also say classroom A or classroom B, 2 different sets of students within the 2 classrooms, okay? So if we look at that decision tree that I had I have it in Canvas, I also have it in my lecture from inferential statistics. Here's our path we're going to take. Am I examining the relationship between variables or the differences between groups? I'm examining the differences between groups. Are the same participants being tested more than once? In this case, no, they are not. How many groups do I have? I have 2 groups, and that will lead you down to the independent samples t-test. So that is step 3 out of our 6 steps for completing a t-test, right? You have to decide which t-test do I use. If I go this way, it's going to be the independent samples t-test. Now, step 4 is computing the test statistics. So we're going to talk about computing it in a totally separate lecture video, but here I want to show you what the Excel output will look like. Okay, it says t-test to sample assuming equal variances. You always want to use the equal variances. Now this is a big table with a lot of information on it. We don't need all of this information. We only need a little bit of it. So I'm going to go through and circle what we need. We need the means. We also have labels here. So we need the means, the group names. You can see this example I've got is males versus females. DF. Remember, DF is degrees of freedom. Okay, that's an abbreviation for degrees of freedom. Okay, 178. You need this information to know how big the sample size is. I'm going to talk about more about it in just a minute. The t-stat, 3.01. This is our obtained value. We need this value when we write our APA results. Okay, you also need the degrees of freedom when writing your APA results. The last piece we need is our p-value. We're going to use the two-tail for this, and here is the p-value over here. Now, if this is less than 0.05, you reject the null. Remember, this is step number 5. If it is greater than 0.05, you accept the null. Okay, so that's step 5 based on this p-value. So, step 6 is writing the results in APA format. Here is the first piece of APA format. It's a statistical shorthand. Now think about whenever you're texting. I have a 16-year-old daughter, and she texts BFFL. What in the world does BFFL mean when she texts me that? I mean, it's best friends for life. Somebody had to tell me that at some point, right? So the same thing is going on here. This is a statistical shorthand, and this tells me everything that I need to know about this test that we did, just short version, okay? I know we did a t-test because there's a t right here. The parentheses is the degrees of freedom, okay, and that's the number from Excel. What I do know, since this is an independent samples t-test, the number here is the total number of people minus 2. So in this particular example, there were 60 people in this sample. Now that's an important thing to know, because if you have enough people in your sample, it makes it generalizable. If you don't have enough people, it's not going to be generalizable. Okay? The next piece is the obtained value. This is from Excel. That's that t-stat, or obtained value. And then last indicates the probability. In this case, I've given an example of p is greater than 0.05, so I know that we have accepted the null. So there's 2 different ways to write the results. After we get our statistical shorthand, you need that. If you have significant results, you're going to write something like this. An independent samples t-test was calculated to compare the mean scores of the experimental group and the control group, found a significant difference between the means of the 2 groups. Here is our statistical shorthand again stating p is less than 0.05. The mean of the experimental group, here's your mean, was significantly higher than the mean of the control group. So I need the means from those results also. Again, this is for a significant result. If you got a not significant result, there's a little bit different way you're going to have to phrase it. An independent samples t-test was calculated to compare the mean score of subjects who identified themselves as morning people, whoops, typo, to the mean score of subjects who did not identify themselves as morning people. No significant difference was found. T2, here's your shorthand, 0.805, p is greater than. The mean of morning people was not significantly different from the mean of non-morning people. What do I see here? This degrees of freedom is really, really low. They did not have a lot of people in their sample, so that's probably why their results were not significant. Okay? Up next, I will talk about t-test for dependent samples.